back to LABrary. I'm Miss Kathleen, and I have a new challenge for us this week. We are going to be learning about archaeology a little bit, mostly about fossils, and we are going to do a fun experiment where we get to excavate or dig out some substances from one of my favorite substances. Can you guess what it is? Well, you can eat it. It's delicious. It does not belong in any of the healthy food groups. It's at the top of the pyramid, if you're thinking about the pyramid. It's a sweet. It's chocolate. Do you like chocolate? There are several different kinds of chocolate. There is white chocolate. There is dark chocolate. There's milk chocolate. And then there are other things that come in chip form that are kind of like chocolate, like butterscotch chips and peanut butter chips. And that is what we're going to use this week for our experiment. The cool thing about these chocolate chip substances is that when you melt them, you can put other things into them. And then when they harden again, you can excavate or dig out the things that are in the chocolate. And then you can eat them too if you want to. So what if in your family you don't eat sweets, or perhaps you have an allergy to something that's in chocolate, or you just don't like chocolate? Well, this doesn't have to be an edible experiment. So there are other substances that you can embed or put things in and then dig them out. Can you think of any? Well, when I was younger, quite a bit younger, I used to like to play in the mud. And I was fascinated with finding things in the mud and putting things in the mud and finding them. So you could just go outside and make some mud with your hose and in your yard. Or you could make it an indoor experiment. You could use, I've got purple Play-Doh. You probably have Play-Doh. If you don't, you could make some. What are some things that you could put in your Play-Doh or your clay? You could put in little pebbles. You could put in buttons. You could put in tiny little animals. Maybe you even have little dinosaur, little plastic ones. Or let's see, what other things could you put in? You probably don't want to put edible things inside because then you can't reuse the Play-Doh. And you might be tempted to eat something that you put in your Play-Doh, and that would not be good. You don't want to eat anything that you have had in your Play-Doh. But you could embed sticks and leaves, anything that you can find outside that's, clean enough, or you could wash them off and then put them in your Play-Doh or your clay, or you could do the whole thing outside. So those are some options if you don't want to work with food or for whatever reason can't, okay? So let's talk a little bit about fossils. What is a fossil? So a fossil is a part or an impression or a trace of an animal or a plant, animals including humans, of a past geological age. So that means that it's been embedded in the rock, so it's preserved in the Earth's crust. And another word for the Earth's crust or the sediment that it's embedded in is called matrix. So matrix is what a paleontologist or an archaeologist is going to dig around to get that object out of the sedimentary rock. So the difference between a paleontologist and an archaeologist. So a paleontologist studies fossil remains. We often think of paleontologists as just dinosaur scientists, and that is a lot of what they do. It's most of what they do. An archaeologist studies human activity through the study of what they find. So studying stuff found in the earth to help us learn about our ancestors, to help us learn about people that lived before us. So why do we care about fossils? What is interesting about them? Well, fossils can give us a lot of information about the past that we never would have known without them. So, like what animals and plants used to look like before our time, where animals traveled, how they traveled, what they did, what they ate, and more. Fossils like footprints can help us learn about an animal's size and shape. There is this very cool video on pbs.org that I would love for you to watch. And it's about fossils. Okay, so let's put the two ideas together. Our experiment is going to be with chocolate or Play-Doh or mud outside. And we are embedding or putting things in our substance, and then we're going to wait for it to harden. And then we're going to dig it out. Except in the case of the Play-Doh and the clay. I don't think you want to wait for those to harden. You might not be able to get your stuff out. Maybe let it harden a little bit, but then it'll be too difficult, I think, to dig out with a toothpick or a skewer if you wait for it to harden all the way. So just that one little caveat there. Don't let those harden all the way. But with chocolate, if you melt your chocolate and put things in it, and then you're going to want to dig it out, you want it to harden all the way. So you can either put it in the refrigerator and it'll harden really quickly, or you can just bring it inside if you've had it outside melting, and then just let it sit after everything is kind of settled in it. You're going to want to have some wax paper or some cling film, some plastic wrap that you're going to put on a surface, and then you'll put your chocolate mess or your Play-Doh or your clay or your mud with your objects in it. You're going to lay it out on a flat surface. And the plastic wrap or the whatever you use underneath it is just for easy cleanup. And I want you to make sure that you share with us whatever it is that you decide to do to excavate this week. And then next week, we will talk more about sedimentary rock. And I might show you a really fun experiment that's really easy to do, just has to do with dirt and water, that will show us about sedimentary rock and how it forms. But for this week, we're going to do the experiment or the challenge with the chocolate or the Play-Doh or the clay or the mud. And please post on social media, or you can put it in the comments below this video. Thanks so much for joining me today. Bye.
Oh. Hello! Hello! My fellow librarians! How y'all doing? I can figure out a better. Hello, librarians! Mr. Travis here. I'm doing a follow-up from last week where we were talking about bubbles and surface tension and how surface tension holds water together. And our challenge this week was to see what we could do to make our own bubbles, but also see if we can make bubbles that aren't round. So we're going to give it a shot and see what happens. So I've got, first, I made a big batch of bubbles. So it's about, 6 or 7 cups of bubbles. I gave you the recipe last week. Here it is again. Back. Okay, so here's our bubbles, and we'll test it out. Basically, I made this a couple of days ago, the bubbles, and I let it sit in the refrigerator overnight, like they suggested. So we're going to give it a shot. So the first thing we're going to do is we're just going to try round. Just a big old round thing here. Let's see if we can get this to make our bubble. Oh, there it goes. Whoa, that's pretty good. So you have to be pretty... I'm finding it, I'm having to kind of put it all the way down at the bottom to kind of get it to hold on. Ooh, pretty good. So it makes big bubbles, but as we find out, oh look, it even made a bubble in my hand. We'll try a square one. As we were talking about, we're trying to make bubbles that aren't round. So we're going to try is making something of a square. Let's see what happens. And as you'll probably saw, and if you tried this at home, just because we make a pattern that is square. Ooh, that one actually blew off. Let's see if I can do it again on camera, actually. The other way. Let me try this too. Let's see. He also said that maybe with a straw. There you go. So even though it's in a square, you're not going to be able to make a square button or a square bubble, because with the surface tension, what it's trying to do, even though it's clinging together, it's trying to get as small as possible. The molecules are clinging to each other, trying to get as small as possible, and the shape that is the smallest in nature, in the most compact, is like a sphere or round. So it's going to want to get round. So what I've also tried to do is I've made some other shapes, like instead of a two-dimensional square or something, I made like a cube. I don't know if you can see it. So we can see what happens if we dip a cube in there. Whoa, it's a windy day. It's a windy day. Hopefully you can hear me. Okay, so let's try a cube. No, that's cool. So, I don't know if you can see this. Hopefully you can. When we do a cube, we get some interesting stuff going on. So you're not necessarily going to get something that's square, but let's see if we can wipe it off. Sometimes you can get, like the cube, well, you can get it to touch a couple of different sides and trap a bubble in the middle. Oh, there it is. Trap a bubble in the middle. And then look, I don't know if you can see that right in the middle. There's a square. So what's happened is it's trapped in the middle. All of these bubbles are connected to the side, and it made a square inside of there. I probably wouldn't be, well, in fact, I know, I wouldn't be able to blow it and have a square bubble fly around. But something like this, let's see if we shake it a little. You can see right here, I've got a little square in the middle of my bubble. Oh, kind of popped. Okay. So that kind of works. So let's see what happens if we do a big, sort of a three-dimensional triangle, like a pyramid. Let's see. So now you can see in here, the bubble is attached. So The bubble, the shape of the bubble is the triangle. If we try to blow it, let's try it one more time. Again, the only way you're going to get a different shape is if it's sort of trapped or holding on to the other shapes. As soon as we blow it out, we're going to lose that shape. You can kind of see in here we've got multiple triangles inside our triangle. How cool is that? And you can try and put some... Alright, and then just for fun, I tried some other shapes. These aren't really any shapes other than stuff at random. I just use a circle with some stuff with a couple of pipe cleaners on there. It almost looks like a crown or something. Let's see what happens if I get that. And, oh, that's cool. So you can see it's got like that crown shape right in the middle. And then it comes up from the bottom. And it's got that crown shape in the middle. So it is actually kind of following my shape. And this is really just a random shape. It's got a circle, but I've got a lot of like connectors sort of in the middle, and it's a circle on top. I have no idea what I'm even trying to do with this, but let's give it a shot. Okay, so you can see I've got all sorts of weird shapes going on in the middle here. There's some sort of crown type shapes, there's some circular shapes, there's some triangle shapes. Let's see if we can... So again, the only way you're really going to be able to get the surface tension to shape, you're not going to be able to blow a two-dimensional, a bubble from a 2D thing like this, and blow it out and have the bubbles actually be squares. Just won't happen. But you can certainly put things together to kind of, basically it's holding bubbles in the middle of other bubbles, and that's the way you can sort of shape things. So we've got on the top here, we've kind of got some triangle bubbles, and we've got sort of a couple of dome bubbles. So the only way you're going to be able to do it is trap it between other bubbles. Okay, so you've got this big sort of rectangle in the middle. You can kind of see that. Got a rectangle in the middle of the rectangle. Huh, that's cool. Try it again. You kind of move it around, you can see, you can almost shape the bubble within the bubble. Okay, see that you can see that triangle, or I mean that rectangle in the rectangle there. And I've made a mess too. I'm getting soapy water all over my feet. So anyway, that was our challenge for last week. I hope you had fun. And I will start coming up with an idea for the week after this, where I'll give you a new challenge. And again, if you made anything this week with bubbles, you want to send it my way. Here's my email. It's travis@mld.org. Just send it my way, and I will post it. And I will put it on our next video to show people what you did. Okay. Thanks, everybody.